and return types. Yes. So these are the function parameters we learned. All right. So we discussed about functions and parameters. Now, another important you need to know about function return types. We have to know about function with return type. So function with return type. Technically, so generally functions, when they have to return a value, what is a return type? These are important. Technically, why a function is designed to return a value. Why a function is designed to return a value. So that is the key point first you need to understand. Why a function is designed to return a value. So that means why a function requires return type. Actually, the answer for this is function requires return type to return a value. Okay. Now the question here is why a function is designed to return value. So what is the purpose of a function with return value? So that is another question here. Why a function is designed to return value? Can you guess any about that? What do you think? Why a function is designed to return value? And not only why and when a function is designed to return a value. Why and when a function is designed to return a value? What do you think? Any of you can guess about it? Returning value. Function itself is reusable. Right? Function itself is reusable. Our question is, so why a function is designed to return value? What you can guess about this? Okay. Okay. Logic callback. Okay. Okay. Yeah. Good. Okay. I got some answers from you. That's good. Okay. So fine. So that means function itself reusable actually, right? So here the point is actually a function is designed to return a value. So when it is designed, so functions are designed to build any expression. When functions are designed to build any expression, they are designed to build any expression. Then every expression must return a value. When functions are designed to build any expression, then every function must return a value. So which is specified by using return type, by using return type. That means the answer is generally we need functions with return type defined when we want to use function as an expression, when we are using functions to build expressions. Usually every expression must return a value, and function is used to build expression, then it should return a value. It should return a value. So which is specified by using the return type, which is specified by using the return type. I will tell you one simple point here. Suppose one simple example here. Actually, so when we are designing any function here, observe. So technically, we are writing a function. The function is captcha. Captcha is a function. Our intention of this captcha function is to return. The purpose of the captcha function is to return a random number. Every time it should return a random number. That means it need to create a number, generate a number, and return that number. Or suppose, I will show you that example also here. Suppose I'm using power, and here power is a function which is defined to return a number, and the power function should return math.pow. So, and it should take the value of x and y. That means here a comma b. So, or here x comma y, and power of x comma y. It should print that and return it. That means we designed a function to build an expression which returns power value. So functions are designed to build expression. This is an expression to return value. So that means when functions are designed to build expressions, then their intention is to return value. Now, what type of value it should return? You have to define the type. And type is defined by using this number. So means data type, number or string, what type of value it should return. So technically, string expressions will return a string. Arithmetic expressions will return a number. Boolean expressions will return a boolean. That means here I am creating another function. Some message is a function. And message function will take a string, so some str, and it returns a string, it returns a string, it returns a string, it returns a string. So some string, suppose welcome to TypeScript, some string it is returning. Or it will just return that string str, whatever the string you define. That means a string expression to return string. Or I will write here dot to uppercase. It will convert that string into uppercase and returns the string. That means you are creating a function as an expression. Then this expression is to return uppercase letters. Then usually expression should return some value. According to what type of value, we have to define the type. So technically, you need function with return type and a return value when you are using functions as expressions. function as an expression, and the values are returned. So the values are returned. So according to the type of the function you define. If it is string, then it should return a string. If it is number, it should return a number. Right. So that is actually the intention of a function with a return type. Return type. Now here, this is how we access it. Message and into this some string. Welcome to TypeScript. That is the message. Now I have some power is a function, and this power function is expecting two values, 2, 3. And very important, they return these values. We need to print them. That means we need to print those returned values. That means this function is returning a string. This is returning a number. Then we have to store in let msg is a string type, is equal to whatever the string return, and let pow so is a number type. It returns the power value, or you can directly print them, and I'm using console.log. I'm printing msg which contains the string. Console.log, I'm printing the power value, whatever the power value found. That means functions are designed with return type. So when we are configuring them as expressions. So functions are used as expressions. When function is used as an expression, it should return a value. That is the intention of doing this. So tsc demo.ts and node demo.js. So that means it is printing that in uppercase letters, and it is in printing the power value 8. So that means it is returning the function. It is returning the function and configuring the function. So the question here is why and when you need a function to design with return type, with return value. So when we are designing for expression, building expression, functions are used for building expression. And when you are building expression, then we have to return the value. This is an example how it can return a value. It is a string, and it is a number. And important is if a function is not intended to return any value, then it is not defined to return a type. It is not defined to return a type. So that means if a function is not intended to return a value, then it is not defined to return a type. So you can configure such functions as void. You can configure such functions as void. That means they are not intended to return anything. Then you can configure that as void. So if you are defining a function, that means generally what is the intention of a function without return type? So that means with void as type. What is the intention of function with void as type? Now what do you will say? What is the intention of function with void as type? What will be your answer? Void as type. First, you understood why a function needs a return type? Clear with that? Why a function needs return type? Right. So when to use void as return type? When to use void as a return type? So when yes, that means already we discussed once this point. I told you special operators. uh, Here, Mr. Ankit, what sentence you have said here, that is completely a blunder, right? You are saying that expression doesn't want to return a value. That is like a mixture of joke, right? Expression means intended to return a value. Na? Uh, an expression means it is expression means it is intended to return a value, right? Intended to return a value. So technically, a function, yeah, actually, so many points are there. See, general point is actually, uh, you should know that. So generally, void void type void type is actually derived from very old languages, C and Algol, actually Algol 68 actually. Void type came from to other languages by using these two, C and Algol, the languages which introduced this void actually concept. So it's very simple. Actually, the point is, so it is a type for the result of the function. That means the intention is does not provide any result as a value to the caller. It will not provide any result to the caller. That means it will not provide any result to caller. It comprises of some statements to execute. It comprises of some statements to execute. It doesn't provide any result to the caller. It doesn't provide any result to the caller. So that is defined by using void actually. That is designed by using void. So that means intention is nothing but, so a function is defined as void. That means its intention is not to return anything. So not to return anything to the caller. So that is void type. So if I don't define void type, then actually in other technologies it is fine, because sometimes I told you that we have methods, we have functions, we have procedures. But compiler is confused about, in some languages it is confused about whether it has to return a value or not. So that means whether this function has to return a value or not. That is the primary concept here. So then in that case, then better to configure that as void type, because if I don't give void, by default it is void. Suppose I am writing a function, some print message, print. This print is a function, print message is a function. And here, so it is defined with no return type here. And by default, it will take it as a void type. You can see that it is by default void type. That means its intention is to not to return any value to the caller. Not to return any value to the caller. By default it is. It comprises of some statements to execute. But this function will not return anything. So if you are defining the function without any return, then use void as a type. I already told you void operator. Once we discussed about in special operators, I given you about it, right? So that means the intention here is to indicate that So the return type is not defined. That means its intention is that it is not returning anything, right? So that means it contains some statements to execute. So it contains some statements to execute. It contains some statements to execute, but it will not return anything. And remember, many people think that these statements are returning a message now. Those statements are not returning a message. Those statements are rendering a message. Returning and rendering is different. So what do you think difference between returning and rendering? Rendering is generating output and displaying to you. That is rendering. Returning means so evaluating a value and keeping it. So this is very important to understand. Actually, returning, returning and rendering and rendering. These are the two key things you need to understand actually. Actually, returning is nothing but evaluates a value. Returning evaluates a value and returns the value evaluates a value and returns the value. So to keep in any reference, to keep any reference and use in application, that is actually evaluate, that is returning. Rendering is nothing but so generating the function, generating the statements, generating the statements and render output as a response. Generating the statements and render output as a response, that is the intention of rendering. So the point here is void is rendering, and with any type it is returning. I hope you understood now. So void is just rendering and type is for returning. I hope everyone is clear about this. Understood? Understood? So that means if you are intending to return, that means you need a type. You are intending to render, then you need void. That is actually technical concept usually. So that means functions does not return a value. Function use some statements which render a value. Functions will use some statements which render a value. Rendering is directly generating the output, and returning is evaluating a value which can be stored in a reference and used in your expressions. That is actually the intention of the void, right? This is what you need to know about void technically. So this is easy to understand. So returning and rendering. And some questions already I told you. So some important questions are I told you. Can a function with the void as return type can use the return keyword? Can use the return keyword? I think we already discussed once. What do you say? Can a function with void as return type can use return keyword? So already we discussed that yes. A function with void can use return keyword. Don't think that return is for return type. Return is a jump statement. So now tell me, so what is the purpose? What is the purpose of return keyword in a void function? void function. What is the purpose of return keyword of void function? Yeah, if you say terminate, coming out, then I will ask one more question. Then what is difference between break and return? Break also terminate na? Yes. Then what do you say? Break and return both are same? Break and return both are same? Break can be used everywhere, not only in loops, right? Yeah. So actually, generally, I will show you the point here. So generally, the purpose of return keyword in a function is to define unreachable code within function. It is used to define unreachable code within function. It is to define unreachable code within function, so that compiler cannot reach the code. Compiler cannot reach the code. And compile it. Why you need some code not reachable? So it is mostly used by developers. So developers in unit testing. That is what actually the intention is. For example, see here, this is void. Console.log, welcome to TypeScript. So console.log, this is second line. So second line. And console.log, so this is incomplete. Don't execute. It is incomplete, don't execute. Now from hereafter it is incomplete, don't execute. But actually compiler will execute everything. Then what we do is we will put here a return keyword. When you put return keyword, you can see that this return keyword can be used in a void function. The intention is, now this, it says that unreachable code detected. That means this code is not reachable. It will be compiled, it will be processed, but it will not reach to this line and execute this line. It will not reach to this line and execute this line. It will never reach this line. Why you are writing a line and you are saying that don't reach to that line? Because generally why we do that? Because that is incomplete. So that needs a complete functionality. That is incomplete. So not reach. Later when it completes, you can reach it. So later when it completes, you can reach it. That means suppose I am calling this function print message. This function will not return the last line. It will not return the last line. It will return only the first and second. And once you finish completion of this, now some more points are there, some more lines are there. So then what we do is we keep return here and some more lines are there, console.log. So this is pending like this. That means now what happens is, now you shifted it to one more line, then it will execute that line and it will execute and configure that line. Third one also executes. We need the functionality to return but that functionality is incomplete. We don't compiler to reach it currently. So this type of approach is followed while testing. I will tell you one scenario generally. Actually, if you know about testing, so general basic scenario. Suppose we are developing an application in that we have a main function and we have subprograms, main and subprograms. The main program is complete. So main completed. That means designed, completed. Subprograms. So one subprogram, these subprograms are under construction. That means our developers are working on them. So under construction. Then my team has to test this main program, but main program is connected to subprograms. Then subprograms are incomplete. We want to test only the main program. Then generally what we do is we put some pseudo programs here in the place of the subprogram, and these pseudo programs generally we call as stubs. By using that stub, we terminate this subprogram. We keep the stubs. By using the stub, we terminate the subprograms. Only main program is tested. After subprogram 1, sub 1, this is 1 and this is sub 2. After subprogram 1 is finished, then what we do is we remove this stub. And we join this and we test these two together. So that means we need to follow a incremental approach in testing every functionality. When this subprogram is completed, then we have to remove this stub and join it and test it. After that, test all the three together. This is what we follow in unit testing. Here you will hear the concept called stub. Sometimes in our project, we will have a main function. This main is under construction. Subprograms are ready because according to the priority we design. Subprograms are ready, main is under construction. Then how you will test the subprograms without the main? In the place of main program, we will keep another subprogram, another pseudo program. So we keep a pseudo program. We call this as driver. By using the driver, we terminate the main program and we test the subprograms individually. When the main program is ready, then generally what we do is, so when the main program is ready, then we remove this driver and connect them and we test them. I hope everyone understood this approach. Generally, it happens in testing. That means subprograms are under construction. Main program is ready. Then I need to test the main program without reaching to the subprograms. Then we need to write a logic in such a way that our compiler will not break. Breaking is different. Breaking means it will jump out of it and it will continue. Na? Am I right? What do you say? Break will jump out of that particular situation and continue with the rest of the things. Na? Am I right? Right? Understood the point? So break will jump out of that and it will continue with rest. We don't want to continue. Nothing is there to continue. You have to terminate there. Then you have to use return. Understood? That means you are not allowing the compiler to reach to that particular location. That is what the intention of this. I hope everyone understood this. That means I just explained this point to make you understand that this answer, that can we have a function void type function, can it use return keyword? Of course, why can't we use return keyword? Return keyword is not only for return types. Return keyword is a general jump statement. You can use anywhere. First, you need to understand its situation, where to use and how do we configure that. Okay, that is one point. So I hope you understood that. That means not reachable. Code is not reachable to compiler. This is just example for that. Now another point here is, so another important point is, can a function return more than one type of value? What do you say? Can a function return more than one type of value? Can a function return more than one type of value? Of course, it can return more than one type of value. So answer is yes, because so TypeScript supports union of type, na? Am I right? Right? Union of type. You have union of type. No need to mention only any type also. Am I right? You can use any type when you are not sure about the type. When you are sure about the type, you can use union of types. Am I right? Right? So you can do that. Union of types. So you can configure union of types, right? So that means here, can we design a function to return multiple? Suppose I said function. So then some demo is the function, or yeah, demo is the function. This demo function is defined with return type as number, and return type as string. It can return either number or string, and it is expecting a value. That is, suppose now you are expecting a parameter param into it. This parameter can be a number type or it can be a string type. It is expecting a parameter or number or string type. Then it can return a number or string. Now here important is, we need to write some logic here. So that means I am writing a condition. If we learned how do you understand the type, am I right? You remember that. If type of is an operator, type of param is equal to number. If type of param is equal to number, then it should return param plus plus. That means it should return the value. So parameter plus plus, that means it should return the value. So that means it is a number. So that means it is an arithmetic operator. So must be type of number. Then it should return that number. That means here I just defined. So operation param plus 1, something like this. But if I am configuring this param plus 1, that means here it is saying that, so you cannot use an operator, cannot be applied to a string or number type. So to string or number type, you cannot apply string and number type. So you cannot apply an operator. Why? I will tell you. So what is the intention here when you define? This is actually one concept you will understand in generic concept. Else I have to define. So else if I am configuring one more here, else if type of param parameter is equal to string, type of param is equal to string, that means we are configuring that as string. So that means the type of parameter is string, we are configuring that. Or you can simply mention, say else, right? You are just configuring it else. Then what it has to return? It should return that parameter. Now here, if the return type, the return type. Here, this is return type, that is the string, the parameter string type, and this is number type. And this parameter so cannot have reference type or number or string type. Just I kept this now. Why? Because this parameter is a formal parameter. And in formal parameter, we are not expecting the union of types. Formal parameters are just memories. And finally, you define the return type that will be used for the parameter type. And if it is number, then it should increment by 1. If it is a string, then it should just return the string. It should return the string. That is what I need to configure here now. That means the parameter is just memory allocated. Its type will be decided by the return type you have configured. Now it can return a number or it can return a string. If it is a number, it can perform this operation. If it is a string, so I want to display. So your message, and I need to print that param. That means the parameter, your message is $, that parameter value. And the value, you have to define that value and configure the value. Right? That means the add addition of the value and present the value. That means now I am calling the demo. Into the demo, I passed it. Here the parameter is any type. And here I am passing some value 10. So it's fine. And demo, into that I am passing some string. So that means welcome to TypeScript. That is a string. We are configuring a string here. Now, when I run this, that means it is returning those values actually. And of course, we need to print them because it is returned with the defined, right? That means console.log. I need to print the number returned, and console.log. I need to return the message they have defined. So that is how we can configure this. Now let's run this, and you can see that it is going to deal with both of them. It is handling a number, it is handling a string. That means, can you define a function with multiple return types, and can a function can return multiple values? So example, it is possible. Yes, it is possible. We can configure this. We have to understand what type of value is passed. Based on that, we can handle various. So can you define with multiple? Yes, we can configure it multiple options. So that is technically how we define the functions and the function return types, how we can use the function return types. So generally the functions and their return types, why we need and how to configure without any return type. That is one point. Another important thing you need to know is about function recursion. Function recursions. Technically, we need to understand about what is a function recursion. Right. So already we discussed, no need to repeat every time. The formal parameters, what are those and how do we use them? From so many days we are discussing every day about the same point, right? Yeah. So function recursion. So technically we need to understand what is the function recursion. What is the type of the function recursion? Here the point is why we are not defining the type of value, because it should be any type, because it should accept any type of value, either number or string. We cannot define the union of type for the formal parameters. It can be any type, right? This we discussed so many times. You remembered? Forgot? Ankit Gupta? You okay with everything? You are clear with everything, but you have always all doubt, right? So this is the function recursions, how we configure and use. Let's see what is recursion. Actually, technically, function recursion is recursion is a technique. So where technically recursion is a technique where a function is called within the context, within the context, within the context. Recursion is a technique where a function is called within the context. That means a function is called within the context. That means within it, within it. So generally, why you need this recursion? For example, suppose I have a simple point here to make you understand about that recursion actually. Suppose I am typing here dir. Dir will get a file list. Some files list is coming. Now I am writing dir. So many times you can see files list is coming. I want this work to be done 10 times. If I want this work to be done 10 times, so done 10 times. So then I will write 10 times dir. That means I will tell you one point here. So see, if you know about general programming related to Windows, I'm creating a batch file, job.bat. So in that, I'm typing dir. That is 5 times I type dir. These are called batch programs, right? Okay. And I finished this. So these are batch programs. This is a batch program. Batch programs intention is to run set of programs repeatedly one after another. Now dir is written 5 times here. I run this job. I will type just job and enter. It will run dir. It will run dir 5 times. Okay, I will type again job. It will run 5 times. Okay, great. 5 times it is executing that command again and again, again and again. 5 times I have written. That job will return that dir 5 times. 5 times, 10 times, 100 times. There is some count we can mention. But if that dir has to run 10 minutes, 1 hour, 2 hours, or it should run until I stop, then how many times I need to write inside it? That means this is nothing like, that means you cannot say loop, because the intention is not how many times, it is how much time. Generally, we need these jobs to run continuously. Several batch jobs are defined continuously to execute. Several batch jobs are defined to continuously execute. Then how many times you have to write to run infinite? So there is nothing like infinite time. There is nothing like infinite time, right? There is nothing like infinite time. So in that case, what we have to do is, I'm doing this technique. I'm writing a program. So job.bat. Okay. This time I entered dir. Okay, fine. Overwrite. It is already there. After that, I am writing job and close. So yeah. So here I am writing dir. After that, overwrite. Yes. Again job and close. That means here I written only 2 lines. The first line is the command. After the first line, the second line is the file name itself is written inside it. Now, what will happen? Can you guess? What will happen? Can you guess? What will happen? Can you guess? That means which command executes first? Which command executes first? Dir command executes first. After dir command executed, then this job file will execute. Job file is the current file. Job file is the current file. That file will execute. If that file executes, that means that file is called within the file again. The file is called within the file again. That file contains again dir. That means this is a recursion of infinite times. Then I type job, you can see it continuously runs. Now I haven't written millions of lines here, but it will continuously run until you stop it. It is infinite now. I have to terminate this job with Control C, then it will stop. It asks me, do you want to terminate this batch job? And yes, then it is terminated. This is a recursion technique. In recursion technique, what happens is a function is called within the context, within that function again. Why to call a function within the function for recursion technique? That means I want something to happen until the condition is satisfied. We don't write any loops for that. We don't write any loops for that. We need a recursion technique. That is what actually the concept of recursion is. That means here I am writing some function. Fact is the function. So this fact function is expecting a number, n. If n is equal to 0, if n is equal to 0, then here I am saying return 1. It will return 1. If it is n is equal to 0, it will return 1. It will stop at 1. So, and else what should happen? Else what it should happen? n into. So here I am defining the function fact again, fact of n minus 1. This is the return option it has to do. So this is, you see, this is the fact function. Inside the fact function, you are calling the function again. This is a recursion technique. That means I am calling here console.log. I am printing here factorial of 5 is, and I am just calling the function fact of 5. I pass that 5 number into it. I'll just compile that here. So here tsc demo.ts and node demo.js, and it should get that and execute that. It says factorial of 5 is 120. Now how this happened actually, that means what is the intention behind this? That means it is a recursion technique. That means initially the n value is passed as 5. Now it is verifying, is it equal to 0? It is not equal to 0. Then it will come into this location. That means 5 into, again the function is called fact of 5 minus 1. 5 minus 1 is 4. And important, so 5 into 4. So after 5 into 4, this function is called again. When the function is called again, this time factorial of 5, that value is passed, n value is 4 now. And it will come into this condition again. This time, so here we have into, again factorial is called here, fact function is called. This time it is 4 minus 1, that means it is 3. And it will execute this again. I am not using any loop here. Without loop, I am making this function to execute several number of times. This type of recursions are required when we want the function to execute up to certain amount of time, not certain number of times. Understood? Certain amount of time, not the number of times. I don't know how many times it has to run. Until the condition is satisfied, it should run. Until I stop, it should run. I don't know how many number of times. I know how much time it has to run. In that case, we need recursions. We need to use recursions. Understood, everyone? So recursion. Understood that point? So what is the concept of recursion? That means recursion indicates that how much time it has to execute, not how many number of times. Right? That is what actually the concept of this. Right? That means if you want certain functionality to happen several number of times, then you can use recursion. So I don't need to give any more examples. You can try so many examples. Right? So this the basic thing. Suppose I want to find the sum of certain numbers. So that means I give a pass in number 10. Up to the 10, I need to find out the sum of all numbers. So all numbers. I need to find out some value like pi. I need to find the values like log. I need to handle some operations until that condition is satisfied. Then for everything, we need recursions only. Majority of all these are done by using a recursion technique. When we want to test several number of times, we use recursion technique. So in various examples, you will see that how to use the recursion, right? Initially, a simple example here to make this happen. We are calling a function within the function until that particular condition is satisfied. Once it is satisfied, then it will be out of the function. So this is a recursion type of technique, how we can manage and use, right, functions with recursions. How do we deal with them, right? These are all general JavaScript basics. You are not learning anything special in TypeScript actually. These are all JavaScript basics that they will continue in a similar way in TypeScript also. If you don't know this, then if you learn JavaScript, you will learn more examples and understand how to handle. I can't discuss all of them now, just basics. What is recursion? I'm highlighting that point. That's, you should know. That's the reason. This is not the time of understanding about recursion. So this is all JavaScript functions based concept only. What is new that we understand, that's enough, right? These are all about the concept of how do we deal with the functions and function return types and function parameters. Now we need to understand another important concept about configuring and working with polymorphism. So other OOP concepts, polymorphism. What is polymorphism? What is abstraction? How the polymorphism abstraction? Abstraction I already told you. So what is polymorphism? How do we configure the polymorphism? So we need to understand about that. So that we will see in tomorrow's session, right? Tomorrow we will understand about technically what is polymorphism and how polymorphism works. And after polymorphism, few more advanced options, mostly by this weekend. We will finish TypeScript. I will wrap TypeScript by this weekend. And from Monday, we can start working with our Angular concept. Okay. Right.